Hi guys, in this presentation we shall learn about opamp as a comparator. Okay, so before going to learn opamp as a comparator, we have to know the meaning of comparator. Okay, so we are comparing. So let's do with an example. For example, if I say that here it's a line called, for example, let it be line be x. Okay, now tell me x is larger or smaller, which means a line is smaller or larger. So there is no perfect answer to that, okay, because if you compare this line with this line, okay, this is smaller. If you compare this line with this line, it is larger. So it depends on the reference, okay, what we are taking. So whenever we compare something, we have to get the reference value. Okay. So that is the idea we have to implement in this op-amp. Okay. So op-amp has many applications. We are restricted to learn only about comparator only, because in IC 555 op-amp is used as a comparator. Okay. First of all, let me tell you some of the pins here. This is non-inverting pin and this is inverting pin, and here is the supply. Okay, and here is the output from where we'll get the output. Okay, how to use this as a comparator? Okay, let's see. For example, if I apply here 10 volts here, and if I apply here 5 volts here, then if the difference is positive, for example 10 minus 5, it is positive, right? If it is positive, then our output voltage will be plus VCC. Okay, if the difference is negative, for example here if I apply 5 volts, here if I apply 10 volts, then the result is minus 5. If the difference is minus 5, then the output will get is minus VCC. Okay, so in general we can write like, see, here we are attaching the reference and here we are giving the input. So this terminal can be written as V in and this terminal can be written as V reference. So I can simply write like, whenever the V in minus V reference is positive, then I can say that the output will be plus VCC. Okay, if the V in minus V reference is negative, then I can say that the output is minus VCC. Okay, so this is how a comparator works in an op-amp. Now we'll see the simulation about this. Okay, in this we can see that here this is an op-amp and here I connected positive 12 volts to here and here connected to ground, which means if it is greater than 0 I'll get 12 volts as an answer, if it is less than 0 I'll get 0 as an answer. Okay, and here from 3 and 2 terminals I have connected to a battery of 10 volts, and I'll place a potentiometer, which is a variable resistor, so that I can vary the voltage. Okay, so these voltages can be read from these voltmeters and the output voltage voltmeter is read from this voltmeter. Let's simulate it and see what happens. Okay, so this is the running. See, whenever the difference is 6.60 minus 5.80, definitely is a positive value. If it is a positive value, it will go to plus VCC. Okay, here plus VCC is 12 volts. Here we got the answer as 11, somewhat nearer to that value. Okay, what happens if I reduce it the value? See, I'm reducing the value. You can check out. You can see that 6.30. I'm reducing the value. 5.90. Okay, 5.70. See, whenever I got 5.60, 5.60 minus 5.80, difference is negative value. If it is negative value, it will definitely go to 0, because here this point is connected to 0, right? See, 0.03. So this is how a comparator works by comparing these values. Okay, this is how the simulation works. Okay,